Hi, pre-calc. We're going to do some factoring today on this video. If you think you remember your factoring really well, you can probably do this at double speed. If you don't think you remember your factoring very well, you might want to be ready to be hitting the pause button because I am going to be going kind of quickly. Factoring polynomials is a way to break down polynomials into products. So there's lots of different styles. One of the styles of factoring is called GCF, or greatest common factor factoring. So an example would be something like this. As you can see, we do not have a product, we have a difference, but we can scan to see if there's any greatest common factors. With the numbers, I see that we have a 4 for a greatest common factor. We're going to pull out an x to the 2. Typically, we pull out the smallest exponent of a variable we see. They both have y, or y to the 1, and then we create parentheses for the redistribution. 4 times 3 is 12, x2 times x to the 1 is x to the 3rd, and we've got our y. 4 times 2 is 8. And I think that's all we need. If I remultiply this, I have 12 x to the 3rd y minus 8y x squared y, and this itself cannot factor more. This is the answer I'd like. Greatest common factor factoring, and that's the first thing you should always look for to see if a polynomial has a greatest common factor. There's also called difference of squares. Again, this should be an Algebra 1 review. An example might be something like this. As you scan through, you can tell there are no greatest common factors here. But this is a perfect square. It's 4x times 4x. This is 3y cubed times 3y cubed. So I'm going to break that down into two binomials. One's a plus, one's a minus. Doesn't matter which order. Like I said, this is 4x times 4x. That goes here and here. This is 3y cubed, 3y cubed. And if I were to refoil that, I will get the original. Do a quick scan to make sure these aren't factorable. There's no GCF here, we're done. So that's how we do a difference of squares. When you have something squared, and it has to be minus something squared. Now there's also cubes factoring. There's difference and sum. This you may not know as well because this is typically not taught until Algebra 2. So difference of cubes, an example would be something like 8x cubed minus 1, where we have a perfect cube, in this case subtracted with a perfect cube. Or you can also do a sum of cubes. 27 and 64 are also perfect cubes. So they both factor similarly. They factor down into a binomial, trinomial. And in terms of the signs, we use what's called SOAP signs. Oh, I think we have some power coming in. Just wait 1 second. So, all right, we have power. So I was trying to do this without power. So the SOAP signs, S stands for same or same sign. O stands for opposite sign, and AP stands for always positive sign. So in this case, the sign started with subtraction, so the same sign would be subtraction. O stands for opposite, so we're going to flip the sign. And the last sign is always positive. And that works even when you're trying to factor a sum. Same sign, so it's going to be a plus because it's the same. The next sign will be the opposite of that, minus, and then the last sign will always be a plus. So in each case, what's being cubed here? 2x, 2x, 2x. 1 times 1 times 1. What's being cubed here? 3y squared, 3y squared, 3y squared. 4 times 4 times 4. So whether it's a subtraction or an addition, you're going to factor cubes similarly. Now in the trinomial, on the outer ends are the squared versions of these. 2x times 2x is 4x squared. 1 times 1 is 1. 3y squared times 3y squared is 9y to the 4. 4 times 4 is 16. The middle term is just the product of these two. 2x. I know you might be thinking, well, it should be negative 2x. Nope, the sign of SOAP always wins. This is 12y squared. But wait, shouldn't it be a positive 12y squared? Nope, the SOAP sign always wins. Okay, so that's how we factor cubes. This is always going to look factorable, but it's not. I think we're done. Okay, so now there's more. There's also the quadratic trinomial. This you've been doing every year since Algebra 1. Okay. Quadratic meaning the highest exponent is 2. Trinomial means it's 3 terms. So an example might be 3x squared minus x minus 14. Okay, 3 terms, highest exponent is 2. Now there's 2 ways to do it. You can do the A times C method. Multiply those to get negative 42. Look for the magic pair of numbers that multiply to that, but add to the middle term of negative 1. Negative 7 and positive 6 should work. That multiplies to negative 42. That adds to negative 1. So then we break apart this middle term into the bits that we just created here. And now we do what's called factoring by grouping, which is where we take out a GCF or do whatever factoring we can with that set. Take out a GCF of that set or whatever factoring we can do. If these two match, life is good. Well, it's time to go to class, y'all. So when those two match, you put them together, then you put the leftovers. Some teachers teach quadratic trinomial just by trial and error. So if you have a trinomial like this, you know it's going to break down into two binomials. It's not a whole lot of ways to get 3x squared. It's probably going to be 3x. And then you look at all the different pairings of 14. Let's see, is it 1 times 14 to get 14? If I refoil, I don't get negative x. Nope. 14 and 1. No, that didn't work. Okay, 7 and 2, 2, 7. Oh, here we go. 7 and 2 should work. 7 times 2 gives me the 14. 7x, 6x will give me 1x, especially if I'm careful with the signs. Okay, so you do whatever method you like, trial and error, or the A times C method. Sometimes you have what I call the quadratic wannabes. So if you have something like this technically is not a quadratic trinomial because the highest exponent is not 2. But because the exponent is cutting in half, just like here it's cutting in half, we can pretend it's a quadratic trinomial. So we can do 8 times negative 3 to get negative 24. Go through the same process, find a pair of numbers that multiply to negative 24 and add to 10. Now be careful, you might be tempted to say 6 and 4, but there's no way to get the signs right. You need them both to be positive to add to 10, but if they're both positive, they won't multiply to a negative. So I think this might be more of a 12-2 combo, 12 positive, 2 negative. That will multiply to that and add to that. I'm gonna do the same thing I did before. I'm gonna break this term into these two pieces, so positive 12x squared minus 2x squared, right? They would recombine to 10x squared, minus 3, and then we go through the same motions we did before. So I'm gonna pull out a 4x squared, and that's 2x squared plus 3, minus, oh, there's not much here, I'll take out a 1, and that's 2x squared plus 3. We have a match, we need that. And then we have the leftovers of 4x squared minus 1. What can make factoring tricky is people thinking that they're done when they've done a process. Always look at your answer. This is actually a difference of squares, like up here. So I'm gonna have to keep going. So this stays put. This is gonna break down the same way this did into two binomials. One's a plus, one's a minus, don't care the order. 2x times 2x gives me 4x squared, and 1 times 1 gives me the 1. Okay, and we're almost done here. I'm just gonna do, I think, a couple more. I'd like to talk a little bit about the perfect square trinomial. Also known as PST. Perfect square trinomial. An example might be something like this. Now, sometimes they end up being quadratic trinomials, so you could certainly factor it the old way. But if you see that this is a perfect square, 2x times 2x, this is a perfect square, 1 times 1, and this is double the product of these two, then it's a perfect square trinomial. 2x times 2x, 1 times 1, 2x double 4x, as long as it's negative, boom, it qualifies as a perfect square trinomial, therefore we write it this way. Okay, so that one, maybe you haven't seen that one much. And then finally, I want to just refresh grouping. We did a little grouping in the last problem, but let's make sure you're comfortable with the grouping. So an example might be something like this. Okay, there's no GCF, 4 terms, so it's not a trinomial. Okay, you pick a pair, you factor it any way you know how. In this case, I'm going to take out a GCF. There's nothing to take out here, but we'll take out a 1. And just like with the last one we did, look for the match, and then throw in the leftovers. Now, you're not done. You always want to think you're done, but you're not done. So you check, make sure. Now, this is a sum of 2 squares. I talked about a difference of 2 squares before, but not a sum. Sum of squares actually doesn't break down, but this is a sum of cubes. So we're going to keep the sum of squares. We're going to break down the cubes into the binomial trinomial. Remember your SOAP signs. Same, opposite, always positive. X times x times x. 1 times 1 times 1. Square that x, put it here. Square the 1, put it here. Multiply them together, put it there. This is going to look factorable because it looks like a quadratic trinomial, but it's never factorable. You can go ahead and try if you want. It ain't going to work. All right, so that was factoring in a nutshell.